Welcome, I'm Bill Wake. We're here working on an assembly language program for a new programming language called 10th that's an imitator of 4th and kind of not intended to be a big language, so just enough to prove out the ideas. All right, last time we worked on add, and we have a test. Let's see, I gotta... No. Okay, the core tests. Push one item, that one worked. Add b plus a is a, did not work. And I think the reason is I think we haven't been consistent about where the stack starts and ends. Okay, so let's see. So push is pretty simple. Where's add? Oh, I think we're still doing it in the test. Okay. Yeah, so the test is we'll push two things on the stack. Let's see, am I thinking about this right? So we have the data is 0. Boy, that's not very... Oh, here's data, 142 and 58. Okay. I guess we're pushing 142 twice. That can't help anything. Let's check for 284 if nothing else. Maybe it's not the stack that's screwed up. I think I meant to increment that between pushes. So we're defining stack-based things on our own stack, and the idea is A and B. A is the top of the stack, B is the second on the stack. That's just sort of a convention, and add should pop two things off, add them, and put them back. Now you can see it would sure be nice if assert equal told us, expected was, or actual was this, and expected was that. We don't know how to print numbers yet, so I don't know. Will that speed us up so much? Okay, my suspicion is, though, that the stack is wrong. Okay, so here we're checking x20 is the virtual... Wait. Yeah, x20 is the PC. Well, okay, yeah. In usage, you're going to have... Oh, no. I don't know what that's doing there, honestly. Well, okay, I guess the virtual PC should move forward. We don't care kind of where it started. Starting an L data is a little weird, but okay. So the PC actual should be the same as L data plus 16 because we pulled the data twice, or we moved forward twice. I don't know. I don't think X20, that seems like a distraction. Let's see. So loading X19 with the stack, that's a good thing. There. And then we put L data here. I don't think we need this. I think L data is irrelevant for us. I mean, X VPC. Notice this doesn't even touch it, so it's kind of not the point. Okay, now the VSP is important. We're trying to make sure that the stack did increase by 8 because we pushed, well, we netted two values if things went right. Push, push, pop, pop, push should leave one thing on the stack, 8 bytes. and we'll check that. All right, and then if we take the stack again and we load 8 bytes off the top. Boy, I'm not very convinced by this down here either, but okay. We load X0 from the stack 8 bytes above, and we want 284. Okay, so our data, oh, I am screwing this up. Okay, the PC needs to be there because that's where these pushes are getting their information. Okay, and push takes it from what's pointed to and increments it, so it should be, I think it should be 16. Let's see if I messed this up. Okay, not so far. Okay, so the pushes need that. We get an add. And so it should auto increment when it pushes. So it should be 200. Okay. All right. Now we load the test stack. I don't know where. Well, let's see. Should we use pre-decrementing index when loading from the stack? Oh, so yeah, maybe this does look kind of weird. Well, it's all depending whether you want to pop it or not. In a way, I don't think we need to, but this, yeah, if we haven't done the decrement, I think this might be more accurate. Okay, so x1 is the back one element, x0 is back two elements, then we add them and stick them back, and we'll store them at well, no, you're right. We're probably okay. Let's back this up a little. I'll just put a return in and we'll make sure nothing passes. Okay. Well, I guess our BLs, this was testing our BLs pushes. Okay. I don't think we need this assertion though, because this is about did push do its job. Okay, so I will take that one out. Then the question I have is we've got the stack. Are we starting off pointing at do we keep the stack pointer pointing at the top of the stack, or is it pointing to the thing just after the top of the stack? I think in some ways it's better to be the top of the stack. Okay, but you got to make sure you're consistent about it. And I don't know if we are. Okay. So we load. Okay, I'm going to put another macro in. VSP is X19. I don't know if this will work. Okay. Let's hold off on this one momentarily. So I'm going to do the technique of visually ignoring it. Let's make sure the first one's right. So SP, that's fine. All right. And then Well, these macros. Do we have core macros? I kind of think we need them. Okay, maybe I'm jumping into refactoring, but I'm losing track of what I'm doing because I don't have these explanations. All right. Oh, let's see. But add loads from, okay, so I want to figure out where push is doing. Okay, so push loads the value from the PC, and this is the post increment, loads the position of the PC and adds 8. Okay. And then it stores that at the stack pointer and then adds 8. So the way our stack is, it's the place that it's pointing to is the next place you're going to write. Okay. And so I think our stack, okay. So the next place we're going to write. All right. So now we have the stack pointer is this. And we'll load data. X1 is the push stack. Okay, and add 8. So we're saying the stack pointer should be 8 more than it was. That does seem right. Okay. And then the value at, I don't think it's, I think this is wrong. It should not be, I think this is it. If you load at the stack pointer, you should get the value 200. Okay. Now I'm going to take this out. Well, getting the rhythm wrong. Okay, it still fails. All right. So the original stack plus 8. Well, I think we could say I almost want to duplicate this up here. So kind of my two pushes, they should have, the stack pointer should be 16 bigger. Okay. I'm curious if that will work. No. Bus error. Now, we're not supposed to have to be aligned to words, I don't think. That's only for the real stack pointer. X0 is the VSP. Okay. X1 is the VSP, the push stack plus 16. Wow. And yet, I don't know if this works. Oh, it does. Good. After add, it should be plus 8. Yeah. So what did I do to get a bus error here? Well, I guess I got to learn to do this more. Core test dot out, and then run. Maybe we can at least see where the bus error is. Okay, it's in assert equal. Oh no, it's in the store. strx0 x9 plus 8. strx, oh, here. Huh. Oh, this is not, well, it's confusing if nothing else. Okay. The top of the stack should be x19, bracket x19. So we load that to x1, and then we're saying, oh, you better decrement. So now the top of the stack is x0. Well, this has got to be 8. Okay, now you're going to add them, and you're going to store it. You're going to add 8 back in. Okay, well, I think that's more likely. Okay, now we got the first one passing. We are going to have to I think we're going to have to get assert equal giving us information. This is kind of crazy. I'm glad to know it failed. Okay, so I load the stack, the original stack. Now, what did we say was going to happen? The push. Push takes the value from the VPC and it adds to it, and then it stores it where the thing is. So the stack. Yeah, I think a pop macro would be a good thing. Okay, so this one is saying the stack, the stack pointer points to the hole. I gotta keep track of that somewhere. Okay. It is to the next place to write. Okay. Which is not, I mean, you just have to be consistent. It's not like it's necessarily good or bad. Okay, so it's pointing to the next place to write. It writes it, it increments it. All right. And then in here, yeah, this is the place that hasn't been written yet. So you're right. We need the other way around. X comma pound minus 8 bang. Like why the other one doesn't have a bang? I don't know. Okay. Oh, are these? How is this treated as a comment? Okay, I'm gonna take it out for now. Okay. X19 minus 8. Okay, so we point past it, so we go back and then get that value. And then we go back and get that value. And then when we store it at the next place to write. and add to it. Okay. I'm used to, yeah, I'm kind of used to this, the push increments. I guess the pop decrements, right? It's got to somehow. It's just before or after is the question. All right. Yay. Okay. All right. Yeah, I think a macro would be good. I think it belongs in like core macros. Let's see. Um, I think I'm rejecting this. We just have to know what it is. This is kind of a note. And then today is okay. Right. So we've got the add primary basically done. I mean, we got to refactor it. Now, so all right, let's do a save, let's do a make and a push. I think there's a like minus capital N will force the make. Okay. This we get add working. Okay. So I'm saying the core macros. Yeah, they're going to be things like push and pop, and if we can get those register references to work, I think they'll be a good thing. So let's refactor. Let's make a new file. Core macros dot core dot macros. Okay. And then we need the make file to build. I almost think this is better. Core.macros, core.s, and then let's put this. Oh, well, yeah. There's another macro. I think there's one to get the base name. Well, let's make it this first. Core.int. Okay. Let's find. I may be misremembering. You use so many different frameworks and tools. Substitution. Yeah, that's the one we're looking at. $add expands the target dependent. No, I guess what I want is not there. Oh, I think what I've seen people do is not Yeah, just not put a suffix on it and then it's the same. Okay. Core.o and then core tests should depend on core macros. And that's that. Okay. All right, so if I do a make clean, a make, core.macros is empty, so it shouldn't affect anything. Okay, and then okay. All right. Now our tests, well, this needs to move over. Okay. Let me add something to the okay. Missing a separator. Okay. That's not it. 43. I suppose I can break them up on different lines. Forgotten how much fun it is to debug make files. I don't think I can just say C like that out. Let's see if this changes it. No. That's a tab. Ugh, I'm not seeing it. Missing separator. I don't think that should matter. Yeah, we got a real tab. It's supposed to be a tab, though. Well, ours doesn't say that. I can't spend all day working on make. All right. Let's see. The real thing is moved add over. Okay. See like op tests. That's a good question. Show invisibles. All right. Let's. I don't know if semicolon was a mixed up character, but yeah. Well, why is that not a tab? Maybe I put these in with the other editor. There must be a setting. It treats it like a real tab, which is the weird thing. No such Ben Shell. How did that run? Oh. Yeah, they should probably depend on these. I don't remember if I had that before or not. I think I did. Okay. Is that my div? Start in core tests.o. Global start. There's start. Undefined symbol. Oh, we didn't extern it. For global. Add seems fraud. It doesn't seem confused. Okay. Good. Yeah, the view was a good idea. All right. Macros. Let's see if these can pull in. Load data. That feels very. That's almost a more fundamental macro. Okay. So, core tests. Core. Okay. All right. Now, I'm curious, can we. Well, to your idea, let's put that pop in. Okay, so a pop. I'm going to pop to a register. T-8. Okay. Now, this then is pop to x1, pop to x0. No matching end macro in definition. I think it's a line thing. Oh, as I want to. Okay. Yeah, thank you. Okay. And then I guess there's a corresponding push. All right. We used it here. Store x0 at x19 plus 8. Okay. Well, that almost. I think that's pretty good. I don't know if this is so necessary. If all your pushes and pops take place here, then you're not too bad off. Maybe I should say push data just to be kind of consistent. But this is, it's coming off the data stack, so I think I want to kind of leave that mention in there. Pop data. Who's complaining? Core.int. Core macros, core S. Oh, we got to save once in a while. Okay, now do the tests need this? Well, I guess we could pop it. Except we're kind of resetting it. Yeah, I think we're not quite using that. Okay, how about here? Store, this is really push data. Register X19 pound 8. Okay. I'm curious if this will work. X20. Well, maybe we do need VSP. All right, let's put this back. Nope. Did I do anything weird? I don't think so. I think it likes to substitute lines. I'm not sure it does a double substitution either. It's hard to know with the way they do things. Okay. All right, the push data, pop data. I almost think those together is its own thing. Well, I don't know. Maybe we'll wait till we see the others, but I think I think there's going to be a pattern that like unary operators need to pop data to x0, binary ones need x0, x1, and then you know, we don't have any triples, so I guess that's okay. But these two, well, we do. There's CAB and some ABC and whatever we had, CBA. All right. Um, well, I think this is adequate. It's all a little. No, this looks like a load push test stack. ADRP add the add off, right? That should be our our load data. Register location, register location. Register location, register location. Okay, so this should be load data x1 from L push test stack. And this is x0. Okay. Yes, unit. Right. Okay. Well, there's two things going on for me here. Let's see. Um, one is I think we haven't touched the dictionary other than to watch it screw up because you can't put the addresses in and we have to do a little jump table-y sort of thing. Okay, grr, but okay. The data stack, we've done a little bit here now. We've got a I don't know what you call a non-array, but we've got a NL takes no arguments off the stack, and push puts one argument on the stack, and then add takes two off and pushes one on. So I feel like we've sort of mucked through getting the stack working a little bit. What we haven't done, well, no, not that. This stuff. So I'm not worrying about the dictionary just yet. I'm pretty confident we can do something at runtime from that table we devised at the end of last week, that can run through and fill in these pointers. And that seems reasonable enough. What we haven't done is this. Well, and also, I'm not sure ret is the best way to get out of a routine in our code. And if we change that, then I'm not sure what happens. So what I would love to do next is make a secondary. And I mean, I think this is, it's our two pushes and an add, but done as a secondary, not as a test. So we don't need to have the routine. This first two bits are used when we're treating it as a dictionary, but when we're running, I think we really need the pointer to this address as the interesting thing. Okay. So I guess this is still a core test. What I want to do is build a structure that is push some number, push some other number, add, and then this link to end. and the address at the start, and then do the thing that's going to make this thing work. It's going to have to keep track of its own little program counter and all that. All right. So I don't. It's funny to me like how painful it is here. Yeah, I mean, just kind of like there's no visual way to get it clear enough to do that. Maybe I'm wrong calling it core, but I'm thinking of core as our basically all our interpreter, and maybe that's too much. But for now, let's try it. Okay, so the test. I guess this is something like secondary runs yielding result on stack. Okay. Now I think our secondary is going to be, let's put it in the data segment, and then we'll get back to the text segment. So this is going to be, primary is hard coded. Secondary is a list of routine addresses that will get called. So the header, at this point, it's kind of irrelevant, but we'll just pretend there's a quad for that. The value doesn't matter. And I'll just say this is the routine name. Well, let's do it the way we should. ASCII C. Add to. Okay, so the routine name. And then we have a link dot quad 0. And this is a dictionary link we don't care about. And then we need the name. This is going to be add to. And I think it's a quad. I don't think there's a problem indenting these. 0, this is push. Quad 1. Yeah, we should do that. Well, I think this is P2 align 1. In a way, I don't care because it's before the add to is going to be the real thing, but maybe it does matter. Okay. Quad 0 push. This is add 0, and this is end 2D. Yeah. Okay. And then that should end that. Okay. Now going to have to do a bit of finagling. Just the test setup is kind of ridiculous. This working around this, I just can't believe. Maybe I need to search this again. Okay. GNU assembler use label as data. That's not quite what we're after. Labels as values. That's going to say C. That's not helping. Yeah, I think we're going to need, we're sort of starting to create the core interpreter, basically. Because it doesn't care. Well, that's what I mean about the endings, whether it returns the right ending. But in effect, we will, the secondary interpreter takes a location pointing at a word that it should run, and it runs it, and that's kind of the way it goes. It's the secondaries need a little more to go on, but that's sort of built into the start 2D is going to interpret that, which I left that out, didn't I? The dictionary, yeah, we need the word. Quad 0 has to be the address of add 2. Okay, yeah. No, I don't care about that. Everybody wants to talk about inline assembly. I guess the word I want is relocatable. No, gee. We're back around. This is very not what we care about. Okay. How to write constants in data segment. No, that's not helpful. x86. Inline assembly, let's see. Whoops, what did he say? And I got a jump table. Okay, I'm going to let it go. I don't know. But it's going to make a lot of work for us. Let's see. The other thing I had was something said, I mean, something said you really were supposed to be able to do this. Dot include core macros sort of thing. I assume it's going to complain. Yeah. Oh, it's not. Okay. I think this is worth fixing then. If I can, I had sworn I had tried this before. All right, if I can include core.macros, then I don't have to do this junk in the make file. Core.o dot o, I think I can just say .o.s. is that. And then core.macros, well, it does affect it, but it should just be able to assemble with core.out. It should just produce core.o. Core tests.int. Well, I guess I gotta pay attention first. Whoops, what was that one? Okay. Yeah. %o colon %s is this. I'm getting a real tab there too. Maybe that's worth a question. There must be an option. Shell variables of the advanced preferences pane. Click tab size pop up in the status bar. Okay. Yay. All right. Oh, cool. That seems like an overdue exchange. Okay, so now assemblers depend on these, or objects depend on the S's. The core.o has to depend on macros as well as S, because either one changing should change it, but it should build core.o based on the other rule. All right, according to me, this should work. Okay. Core.macros, core tests. Core test.int doesn't seem to be a thing anymore. Oh, but core tests does. Core test.o depends on all these. Well, I guess I could have said .o. And let it do its thing. ASUnit.o. See like core tests. Okay. All right, that's that one. Ceiling cannot specify .o. Yeah, it would have been nice to know which line you're complaining about. Cannot specify -o. Well, that one. Core depends on core macros, core .s. Okay. This core test.o depends on that stuff, and he's built the same way. Core test.out. Okay. I don't know if that's minus O. I think I've got a AS core test. Let's AS core test.o, core test.int. I don't see core test.int in here. I've saved. Core test.int includes macros. Okay, core needs to include them too. Yeah, 3.1. Dot recipe prefix. But I'm puzzled. Is it, who's complaining here? Is it's core tests? All right, let's try this. Make clean. Make core.o. All right. Surprised by the spacing. .o.s. Okay. Core test.o. Oh. It depends on Unix function macros. Okay, so let's get that in there. ASUnit.macros. And I think it's to some extent, I think the convention's kind of more like you want your target first. Okay. Okay, so we can build core test.out. Now let's look at core test.out. ASUnit.o. I'll do this again. I don't think it really matters, but out from O's is that. Okay. Okay, so let's make core and core tests use dot include. Okay. Now, well, AS unit feels more fundamental. I'm going to move it up for our purposes anyway. There's the core stuff. Unit test demo.o depends on .s. And it should take some of these macros. Unit test demo. Okay, we said it depends on Unix and AS unit. Unit test demo.o depends on these. Yes, yes. Unix exit. Yeah, I got 381 as well. Okay, so Unix exit must be a Unix functions. You would think. Unit test demo 21, unrecognized instruction. Test demo includes this. Unix function macro is that. Am I not saving again? It's bad. Okay. Okay. I keep hitting Command C for committing my stuff. Let's see. So we make unit test demo use dot include. Okay, one more. Unix function macro. Okay, c-like.s. Depends on Unix function macros. C-like tests depends on these two. Oops. Okay. All right. Well, I think that's a good place for a break. Be back in 3 or 4 minutes. Welcome back. I thought it was 10 minutes further along than it is, but oh well. Okay. I see we left a little bit of INT stuff in here. So let's do, well, ls. We got these INT files around. Yeah. Let's make clean and make and look again. There aren't any. Okay. So we can make tests just to make sure. Make sure we're good. Okay. And then it doesn't need to be mentioned here. Okay. All right. Now the moment I've been putting off, I guess. Okay, core tests. So, well, trying to make it slightly better for this. Also, I had an idea while we were on break. I wonder if we can get these BLs automatically assembled together. I'm gonna have to think on that one. I think there might be a way. All right. Okay, so what has to happen is, I guess, like phase one, we need to store addresses. Um, so we've got load data. Where's our core macros? I guess I'm starting to feel squeezed. This one almost doesn't matter because we're just looking at the red-green stuff. Okay, and I guess quarter macros. Load data. It really is not load data. Is it getting, it's really loading an address? So now I have the register has the address in it. Let's see where that's used. Load data x19 is the address of the stack. Yeah, let's change that. Oh, they're backwards. Okay, save all. Right. Okay. So the test then, we're going to load address. I guess we'll get x0 to be add to. I don't really want soft tabs anywhere. Okay. So we got the address for add to, and we want to move. I guess we got to load the addresses for push and add and N2D. Push. Which doesn't exist. Okay. Okay. And then we got to store. I guess we want to store x0 into the location for x0. I don't. And that's what that does too. It stores location at the thing. Okay, and I guess we can push store x0 to x0 and then add 16, no, 8 bytes. Okay, so we'll have written this and moved x0 to the address of the push. And move forward. Well, this time we want to move forward 16 to skip the data. Store x2, no, x1 again. And we'll skip 2 again. And then we want to store x2, x0, skip 8. And then we're going to store x3, x0. And we're done using that address. Okay. So I think we've built build our secondary. All right, so let's go back to the picture. So we have the address of, oh, we want start 2D. Yeah, we want start 2D. All right, so x0 has to be start 2D. Well, no. Well, we put it, I don't know, x1 start 2D. push x3 is add x4 is into D. Okay. So start x0 gets that's x1 gets put there, x2, x2, x3, x4, and we're not skipping anything. Okay. Start 2D is going to be the bit of program that maintains that virtual program counter, and it's going to work its way. So it's going to be the thing that knows first we're going to execute push, then we're going to do the next thing, then the next thing, and the next thing. So they kind of have to work together jointly. And I don't think I worry that we're going to have to get rid of the returns everywhere. We'll see. I'm pretty sure you don't really need them, and to make these things symmetric, they all kind of have to be the same. So I don't know. We'll see. Ret is a bad thing for it. It's not what we want. Okay, so once we have these things, well, I think we're going to need, I think, add to, so the interpreter is going to have to know the address of the block. Okay, so add to, I think we're going to reload x0. Okay, so we're trying to get things ready for something. I don't know, is it well, there's something that's running, and maybe it's start 2D. You give it the address of this block. Yeah, it's kind of the main of the interpreter, but I think it's also kind of blended in with it. So I'm not quite sure we're right, but if you, I think we're kind of programming start 2D. Okay, so if you get the address of a block and you give it to start 2D, it should load the address pointed to by that, call that routine, which will be start 2D, and let it do its thing. Okay, so the sort of seed of the whole thing is very close to start 2D, I guess. Maybe that's too confusing. I think we'll pretend there's something else around. Start interpreter. And okay, we'll make everything return. So I think this, let's test this main routine that's going to be responsible to load, well, it sets its initial PC, and then it's going to call whatever the starting block is, which in our case is add 2. Indirectly. Yeah, we're going to pass that address in. I think that's going to be what we do here with x0. So I think this is phase 2, I'll say it that way, is pass the secondary to the interpreter. All right. And then, I mean, this is really just a range act assert, I guess, because for whatever version of this is, Yeah, so I think start interpret well, if we do this, let's assert. Okay. Check that stack contains right answer. Okay, so I don't usually pull out the names of these arrange act assert. It's kind of in normal code it's kind of a bad sign if it's too complicated to see, but I think this is just sort of the way it is. We can make a helper, but I don't think we can take arbitrary stuff. Maybe we can. Maybe we can do default arguments and let it go. But anyway, yeah, we have to put stuff in that's not there. Okay, so if you start the interpreter, what should happen? Well, we're going to check. I guess the stack, like it really needs to be the real stack at this point, which we haven't really defined. And maybe this is not core. I'm almost thinking it's not. This is almost like interpreter, and maybe it should be its own thing because it's going to contain all the stuff, but it's going to have to seed things too. So let's make a new file, and this is interpreter tests.s. Okay, and like core tests, we're going to need, well, we'll probably need all three of these. Okay. And then test start all this for now. We haven't busted these out into their own file. There will be an interpreter.s in a bit. Okay. So we have, well, let's see. I mean, we want to, let's load the stack pointer into x0, x19. Okay. And no, this is, we're gonna put the stack as actual data here. This thing is so obnoxious about where it puts tabs. Okay. Yeah, that would be a better start, wouldn't it? Okay, let's do that. Let's put the stack pointer dot data. I want that inside here. Dot data stack. Fill. I'm just gonna put 10,000. Okay. Yeah, let's save. Okay, we won't run that one. How's that? Okay, so we have a global start. This is so doable as a test macro. Okay, let's get, we'll run only one thing. This is like interpret empty program. And I think I'll put these up top. Okay, so I'm saying give me 10,000. Yeah, it really is a mixed thing. I'm not sure we'll be able to separate them fully, but we'll see what happens. Okay, so now we want a new test. Interpret empty program. And yeah, you're definitely right. That's where we needed to start. Okay. Now we still need this stuff. It'll be smaller. Okay, so after the data stack, let's put another data segment. Good grief. No, it just puts them in. Well, that's redundant now. Okay. Test. Okay, dictionary link, we don't care. Address of start 2D has to be there, but then the only thing left is address of end 2D. So that's an empty program as far as we're concerned. Okay. And we got to do a little of this. Oops. We'll address x0. We'll get, let's call it local empty. Okay. Now we're going to call our interpreter. So this is pretty close. Oh, we gotta fill things in. Okay, so we'll store. Nope, we gotta do these things. We need start 2D and end 2D. We'll store x1 into x0, move forward 8. We'll store x2 into x0 and not need to move forward. Okay. Okay. I saw something that Xcode can run your assembly programs too, so maybe I'll take a little time and give that a try and see if it's got to be better than this. This thing is super annoying. Okay, it's trying, and we don't have an assembler. We have the MIPS assembler. I don't think that's any. I don't think anything else looks. None of the others were assemblers, so they're probably even further out. Okay. So how are we going to know this thing worked? Well, I mean, I guess we get here. Yeah, assert VPC. So we need. I guess that's x2 plus 8. Well, load. I mean, if it just gave me completion, that would be a huge step forward. X0 L empty. Okay, so that's the address there. And then we want to say X1 is, well, what should it be at this point? Should it point at the last one or the next one? I mean, it starts off, it's going to point to the first one executed. So it should point after the last one, I guess. Add x0 gets x0 plus, well, 0 plus 8 plus 16. Well, that's x1. Yeah, well, I mean, we're sort of deciding that, but we have to remember we have to keep the assembly routines have to follow the same process. So, well, they don't have to. We could design a different thing for them, but they have to be somehow triggered from the same thing. Start address just wants to say, I'm going to take whatever routine that is there and run it. And if it's assembly, it's pointing to itself and you just run the assembly. But so the ret at the end that we have seems like it's not going to be the right thing. It really should jump back into the interpreter and it should do an N2D basically. And this is us figuring out how to get from an N2D to actually anything. I'm not sure what happens. Okay. And so I think this is kind of like a run interpreter, really, isn't it? Okay. Which maybe just interpret even would be even sufficient. Okay, but we want to get the, well, we want to move x0 gets x20. That's the virtual PC. Okay. And now this should be our BL assert equal. Okay, so this, all right. So set up the data, the block, point the initial address at the start of the block, and then run the interpreter and make sure that the VPC is 2 steps past where it started. And like you say, it may be we want to assert where it started. We can adjust. All right, and we're only running this test. Okay, and we haven't put it in the make file yet. And what do we include? I think it was Unix functions. Oh, all 3. Unix functions core and as unit. Is there anything else? See, like we're not using yet anyway. Okay. Now, should fail the test if it doesn't blow up sooner than that. Oh, I didn't put in the output. No rule to make target needed by interpreter test.o. Make target Unix functions dot macro. Oh. Okay. No rule to meet target Unix functions dot macro. Well, why isn't it complaining about core tests then? Macros? Ugh. Interpreter test.out cannot be opened. Interpreter test.o. Make interpreter tests.o. What? Interpreter tests.o depends on interpreter tests.s. What? How is this up to date when it doesn't exist? Okay. Something.o depending on something.s should call as. Test.o depends on interpreter test.s. Make unit test demo.out.o. .o. Well, I don't know if the O file depends. Oh, I guess it does. The out file does not. Oh, he needs AS unit. C like unit C like core tests core. Everybody else's gets built. What? Oh, I didn't put the start? No, I did. Okay. I don't think that should matter. It wants to make those. Well, is that? Oh, stupid. Huh. Wow. Okay. Burned by spaces again. Let's comment these out for now. N2D referenced from start. Print. Okay, if we need print, I guess we do if we're doing assert equals. Okay. We're getting better. N2D and start interpreter. Who's complaining? Interpreter test. Undefined symbols referenced from start. N2D and start interpreter. And oh, and I changed this name. Missed one. Undefined symbols. Nothing referenced from start. I don't even know what that means. Do I have a blank as a symbol somewhere? I don't think these spaces should matter. That's back in text. We're in text, start, run interpreter, start to D, end to D, go back to data, do some stuff, some more stuff, go back to text, do our stuff. Last line? Really? Oh, golly. I guess I never even put it in, probably. Who knows? X19 referenced in. Oh, that's supposed to be a label. Is that what I call it? Data stack. That's the test we're not even working on. Okay. Fail. All right. Yay. Okay. Well, okay. So let's take. Well, see, I guess this is where I mean, we can easily pass if we do add x20 gets x20 plus 8, 16. I think we'll pass, but it's not doing much. No, it's not. Okay. Interpret empty program. Am I asserting the right thing? Well, we have to start x20 somewhere. X0. Okay. Well, that's good initialization. All right, we're progressing. Okay, but we're not doing anything yet. I think we can do it under this test because we're not actually running anything yet. All right. We want to establish our stack pointer. So let's put that in. Load address x19 gets data stack. Okay. Yeah, I mean it's a step. All right. So we've got to load x19 gets the stack, x20 gets x0 because that's the starting point according to the call of the interpreter, and then he should. I don't know. I think he's just supposed to branch. It's kind of tricky thinking this through here. Okay. He he should look up whatever's here. I don't think he needs it anymore. Okay, so let's move x0 gets whatever's in x0. Okay, so we're going to put the data in the contents of the VPC, the virtual pointer program counter. Our program counter is going to go take whatever value I'm pointing to, and let's load that into x0. And then he should do I think it's just a branch. It's not even BL, I don't think. I think he should just give control to that. And I think that's the thing that makes this whole threaded thing work is like you just it reminds me a little bit of something else I kind of half understand, which is continuations. But continuations, you sort of pass along the thing you want to go to when you're done with this. And this is kind of doing that. Um, I actually think it's not X0. I think it's X20. I think you're doing this. So you're going to, oh no, you don't want to add to it afterwards. No, it's not X20. Um, okay, we moved X0 into X20 because it's the pointer to the block. And then we want to, I think, well, I think I've seen it done this way, like PC X0. Plus, and then I think we want to move. Let's see. So we want to jump to whatever address the virtual program counter points to and let it take over, and we increment our pointer. Yeah, that should be well. First, let's see. So what we're doing, I probably should make a better picture, but um, we're saying virtual PC starts out pointing here. We're going to say jump to whatever address this is. So start 2D is the thing that will set things up so and start walking through this list. And then until it hits N2D, which is kind of the pop of that. And I don't know if there's a real pop in there or a real return somewhere because start 2D is not going to, well, how is that going to work? Maybe it is. Maybe it is just a branch linked. I don't know. We'll have to, that's what we're figuring out, I guess. But I think that's right for now. Okay. So I think we we have to move the program counter because we handled this. We got the address and we branched to it. And now it's going to pick up the virtual program counter and get the next thing. And we've already incremented it and it's sitting there ready to go. So I think that's good. And then let's make start 2D just let's make it do kind of an increment. Start 2D. I'm just kind of pushing the work down, but we already incremented once. We're going to pretend we executed the next statement. So we really should. Oh, yeah. We really should. We've skipped over the start 2D. We really should be pointing here and do whatever N2D does, and somehow between them, they should increment that virtual program counter. So we're going to make start 2D pretend it did everything that made that work. No, we're not even calling N2D yet. Nothing's looking at it. But I think this is another kind of stage, and this is this is I'm not sure how to call it, but it's a technique I learned from Kent Beck really in TDD style stuff. That's It's like you're using your test to pin down stuff around you, and then you expand, 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 and the test doesn't. It still runs. Originally, it's like when you just return one for the first time you run a test, and then rather than writing the two, you just kind of keep expanding it to grow into the right thing. Not all the way, but just kind of within the natural bounds of it. And so for us, we know start 2D and end 2D should run. When we get to the point those both are involved, I think we'll say that's good for test one. Okay. Now, how do we jump indirect to a PC? Branch indirect. I don't know if that exists. BX? No, we don't have BX. LDR PC. Do we do LDR? I did that move. Okay. Load our PC. Okay, and this return never gets executed, so it's weird. Unless, well, it does because we get returned from that. No, it doesn't. So we're never adjusting the link register, so nobody can do a return. I don't know. Load PCX0. Maybe you can't do this #8 on it. Okay. Is that what they showed? That. Load our PC is not possible with dedicated register. RV8 ret is analogous to BR. Maybe BR will be our thing. BLR. That's gonna be a minute. Well, that's the thing. It doesn't know. So that's the tricky part of this. For an assembly routine, that address is going to point to itself. So we actually, our next test is probably like write an empty core routine that does this. How's that going to be? So yeah, let's go back to this. So see here, this address of code points to itself. So when you call that, you did the same process. You get the address and then you indirectly execute it and jump here. Now, this one will jump to our assembly code and do whatever our return is. This one jumps to our start 2D that walks through the list, but they're the same. Yeah, I think we don't even need a no op, just a return or whatever the equivalent is to test this empty one. All right, but you're still overlooking that document. Gosh, can't use LRR0 label. Yeah. I think I'm waiting for the ARM documentation. ARM. Okay, well, that's a good question. Oh, maybe this guy's got a good article on it. Unfortunately, I don't think he has a list of all the articles. Control transfer, that seems promising. Nope. How's this thing doing? Still loading. Classic function prologue. Nope. Lots of good stuff, but I don't think any of it's what we need. Other kinds of classic prologues. No. All right. Do we have this? No. Let's see if this comes up any faster. Oh. Well, these are LX3. Yeah, there we go. BR. Not found. I don't believe it. C3 is 162. I'm freezing up. Oh, this isn't it. There's a download here. Try going back. I don't know. I was thinking BR was branch register. Okay, excuse me for just a minute. Okay, not BR apparently. Did this get down yet? Must be huge. We had LDR PC before. Okay, are these links? Yes. Okay. Conditional branch, unconditional branch, immediate, unconditional branch register, C3163. Oh. Okay, BLR branch link, BR branch to register. Change the flow unconditionally by setting the program counter. BLR writes the address of the sequentially following to X30. So let's look at BLR and BR. BLR, branch link to register, call subroutine or address in a register setting PC forward. I don't think that's going to quite help us. Okay, and then I think BR was a little further down. BRXN does not let you do any other modes on it, apparently. Okay. All right. Oh, does okay. I'll have to reread some of that. Okay, so we should be able to say, okay, I guess what we got to do is increment move x one, well, x zero. Wait, we move x20 to x0. So we've got, no, x20 gets x0. X0 is still the address of that routine. I think this is add x20 equals x0 plus 8. And then we want to branch to x0. Okay, so I think this is moving. We're setting the program counter just past the routine here. So 8 bytes because that's 64 bits. So x20 is now here. And then we're jumping to x0, which is the routine in there. Yeah, I think that's what we want. And that's a branch, so there's no returning from that. Okay. I've been doing lowercase for non-macros. Okay, and then that should get us to start 2D, which should do this and then do the return, which is not really quite right. Maybe we'll pull that fourth documentation up. Bus error. Oh. Does that mean that is not? This, I think we need 2 bits. Or maybe there. No. Okay. All right. Well, I think something's close. Are we getting here would be interesting. Yeah, it's like it's got a weird address or something. We'll go in the debugger next time and see what those addresses are. And I'll take a look at that fourth chapter. I didn't reread my fourth books before tackling this, I guess. I focused mostly on that threaded interpreter book. Because I'd forgotten he'd even discussed that. The other thing we can do maybe is, well, I think it's got to be the branch that's blowing up. Because an add shouldn't care, just add stuff to register. That's pretty generic. Load address should be fine. I mean, we've aligned it pretty well. And it's the PC that's doing the actual branching through. Unless we've got a bad address there. But okay, can't do it now. All right, let's see. Tomorrow's Wednesday, so 2 to 4:30 p.m. Eastern, 7 to 9:30 p.m. UTC. We will pick up on trying to get the Start 2D and 2D stuff working and see what we can learn. All right, thanks for joining today. Made a little progress. I think once we get through this interpreter, things should pick up a bit. All right, take care. Bye-bye.